be showing you as per the topic that what is a tester, and you will get a brief idea that what is a diode and what is an LED. So in your book on page 174 there are some diodes given. There is an LED mentioned in your book. These are two LEDs, and these are normally fitted in every device where we use a low voltage. So in this you can see that one of the end is small and one is big. So you can see here that this is a small end and this is a longer end, and the two ends are used to differentiate the positive and the negative terminals. That is why they are made longer and shorter. Otherwise, when you connect one terminal to the positive, the other one naturally becomes negative. Positive and negative terminals are there. Now in your book there is a mention of a tester. So I have got a tester. And what is a tester? In this, these LED bulbs, which are, I have connected them with a wire. So this is a bulb, and this bulb I have connected with two wires. So the two wires are used with different colors so that you can differentiate that what is a positive and what is a negative terminal. So in a battery you must have seen that there is a positive and a negative terminal. So the positive and negative terminal varies in different batteries. Now this is a battery, and in this you can see the specifications are given, and you can see it is showing plus written here, and on the other end there is minus. So it has got two terminals, one is positive and one is negative. Normally a battery or a cell which you use at home, these are two types. So one of them is this is commonly you must be having at home. In this there is plus and minus written. So towards this side it is written plus, and towards the other side it is written minus. So at home you can check this battery also. So here you can see it is written plus and minus. So the positive terminal and negative terminal, the positive terminal is called the anode and the negative one is called the cathode. And this is something which is not described, but let's understand that. So this is a low voltage cell, and to make a tester I am using a slightly higher voltage. Otherwise I would have to use 2 or 3 batteries of this type, join them together and then make. So instead of that I am using this battery, which is of a, and in this the two terminals are plus and minus, which are mentioned. So this side is minus and this side is plus, and they are connected with a wire. So this is a wire in which there is a cap. So I will connect it on the two terminals so that it does not become loose. So it is connected like this. When it is connected, this makes a circuit. Now you can see that there is a wire which is red and there is a wire which is black. So one is connected to plus and one is connected to minus, and the two wires are connected to a bulb, which is the LED bulb. Now when I will connect the two wires, here the two wires are not connected, so the bulb is not lighting up. When I will connect the two wires, then the bulb lights up. So this bulb you are seeing, it is lighting up and it is showing different colors. This is a low voltage, it can work with this battery. So this is a simple tester where the two wires are not connected, so the bulb does not light up. But when we connect the two wires, the bulb lights up. You can see that the bulb is lighting up. If I will put any appliance or some object in between, and if you put a solid object in between, then the bulb will light up. But in this chapter we are doing a chemical effect of current. So if I put anything in between, like if I put my hand or a finger in between like this, the bulb does not light up. So one of the reason is that it does not mean that our body is not a good conductor, but it conducts. But since the voltage is very low, so there is no effect on this. If I will use any metallic object and connect in between the two terminals, the bulb will light up depending upon, like if I use a metal wire, a metal scale, and I connect it on this, you can see that the bulb is lighting up. So this is one terminal and this is second terminal. When I put the two ends of the wire on this scale, the bulb is lighting up. You can see when I touch, this is touching and the bulb lights up. So this means that this metal scale is a good conductor of electricity. If I use a paper, the two ends of the paper, when I connect, the bulb does not light. So the electric circuit is incomplete. The current should flow from the battery to this wire and through the bulb to the other end of the wire, and it should go to the other end. The current must flow from one end of the battery to the other end. It should flow from black wire into the bulb, and from the bulb through the red wire. It should complete the circuit. It should flow. When I will put this wire on this paper, the current should flow through this paper, and so but the bulb is not lighting up, which means that the circuit is incomplete and this paper is a bad conductor. Now let's test with liquid. So if I use a liquid, like if I am using a liquid which is, but before that there is an activity 14.3. If you see activity 14.3 in your book, they have mentioned a magnetic compass. So this is a magnetic compass. So you can see this is a magnetic compass. The red part of the magnetic compass is automatically pointing towards. If I turn it, there is no effect. It is always pointing towards one direction, which means that where there is red, there is the north pole. So where I am sitting towards this side, there is north. Now, in this activity, it shows that if there is electric current flowing near this magnetic compass, this magnetic needle will be deflected. Let's see it happens or not. Now here you are seeing that the battery is there. If I put the battery, nothing is happening because the current is inside the battery. Now if I use the battery and connect the wires, the bulb will light up. You can see that the bulb is lighting up. Now if I bring this battery and the current near this magnetic needle, there will be effect on the magnet or not. Now this magnetic compass is, it is moving freely when the needle is kept free. It should be kept at a particular angle. Now if I connect this wire, the current will start flowing, and if I bring this magnetic compass near this, you will see, you are seeing a deflection because there is current flowing. If I remove this, then the magnetic compass stops moving. If I bring this magnetic compass near this electric current, then there is deflection. You can see that the magnetic needle is shaking. So it is shaking because the current is flowing through the wire. So this is also a tester. Where there is a magnetic field, where there is electric current, there is a magnetic field. So this magnetic compass is also a tester. If you use this magnetic compass and keep it near any electrical device which you have at home, then you will see that the magnetic compass will be deflected. It will start moving. So it is deflecting there is a magnetic field, and wherever there is a electric current flowing, magnetic field produced. Now bulb is lighting, so there is current, and if I bring this current carrying wire near it, the magnetic needle is deflecting. Now there is weak, very less deflection in the magnetic compass because the current is very weak. Okay, so this magnetic compass activity is 14.3, which is described where you can test without a bulb also. But we will test the liquids with the help of this device. So I have got this circuit completed, and I am using a container in which I have put oil. Now this is oil, and these are two containers in which there are different oils. So when you do the activity, you have to make sure that the two wires which you are showing the activity, they should be clean. And when you dip them, now this circuit is incomplete. If I put anything in between the two wires, the bulb will light up. The bulb will not light up if the circuit is incomplete. Now if I take the two wires and put them inside a liquid, let's put one liquid only. Now if I put the two wires in this liquid and the bulb lights up, this means that the liquid is a good conductor. Now I have put this inside the liquid and there is no effect on the bulb. So what does this mean? That the liquid is a bad conductor. So this liquid, I know it is, this liquid was turpentine oil, and turpentine oil or kerosene oil, they are not good conductors. So the bulb does not light up, which means that this liquid is a bad conductor of electricity. Now this is oil, the normal oil which you use at home. I have cleaned the two wires because they might be having oil. Now I put the two wires again into this oil, and the bulb will be working, bulb will light up only when the circuit is complete. So if I put the two wires in the oil, now you are seeing that the bulb does not light up. The bulb is not lighting up, which means again that this oil is also a bad conductor of electricity. Mustard oil. So it means mustard oil is also a poor conductor of electricity. If we use water, then in water it will show a good conduction of electricity. So if we remove this, this means that it is a poor conductor of electricity. And if I touch, then the circuit is complete. So this is a simple tester which is used for testing the conductivity of a liquid. I can test it with different substances. If I use, I show you the activity with the help of water. If we use water, what do you think will happen? It depends upon the type of water. I am using normal tap water. In your book, it is given, there are different liquids mentioned in your book. If we use those liquids, then the activity can be done. Now I have got water here. This is the normal tap water. Distilled water is not there. So let's see if we put this in the water. The normal tap water, it conducts. Now you can see this is the normal tap water, and I am putting the wire inside, and you can see that the bulb is lighting up. What does this mean? That the tap water is a good conductor. If we use, let's remove this. If we use distilled water and we do the same activity with distilled water, we will see that the bulb does not light up. Why? Because distilled water does not contain any impurity, it does not contain any salts, so the bulb does not light up. So this is the working of a tester. In your book, in the book it is showing that there are some liquids mentioned here: lemon juice, vinegar, tap water, vegetable oil. So we tried it with vegetable oil, with milk, with honey. You can try it with any liquid. I have shown it with this. I can try it with color. I can try it with water. I can try it with. So we have to use any liquid. So we will see that if you dip the two ends of the wire in a lemon juice. Now lemon juice is an acid and an acid is a good conductor. So we will see that is why it is written yes, and it is a good conductor. The bulb will light up when you use a lemon juice. If you dip it in vinegar, vinegar is also an acid, so you will see that the needle will show deflection. And this means that vinegar is also a good conductor of electricity. If we use tap water, I have shown the activity, vegetable oil also, milk, honey, you can try it with different liquids. They will show different behavior. If any substance is having large amount of salts, then it will behave as a conductor. If it does not have impurity, then it will not behave like a good conductor. So there are some columns which are left blank. From this you can see different names. You can try, you can try, I have tried with the kerosene, I have tried with the turbine oil, you can try with kerosene, you can try it with petrol also. So you will get different answers, and this shows that liquids are behaving like good or bad conductors depending upon their property, which is tested by a tester. So from table 14, we find that some liquids are good and some are poor conductors. Now this point which is mentioned here says when the free ends of a tester do not touch each other, there is an air gap between. The tester which I have shown you, the bulb is here. So if, why is the bulb not lighting up now? Because the two wires are having gap of air. When you bring them and touch, then the bulb lights up because you are directly connecting one wire to the other wire. If there is air gap in between, the bulb does not light. What does this mean? That air is also a poor conductor. So in the book, it is showing that air is also a poor conductor of electricity. But during lightning, an electric current passes through the air. If air is a poor conductor, then how does it become a good conductor? So, because during lightning, if air is indeed a poor conductor under all conditions, this makes ask whether other materials are poor conductors, they also allow. So air allows electric current when it is having moisture. So during when there is a thunderstorm, then you will see that there is lightning, and if there is moisture, it is about to rain, then there is lightning and you will see it happening. So under some conditions, this is a point mentioned here. Under some conditions, most materials can conduct. That is why it is preferred to classify materials as good and poor instead of classifying as conductors and insulators. So good and poor. We will not say that they are totally insulators. Some substances may behave as insulator under some conditions, but under different conditions they may conduct electricity. That is the meaning. So some substances will behave as good conductors, some will behave as poor conductors. instead of calling them as totally insulators, we should say that they are poor conductors. So we have tested of electricity through tap water, the conduction through distilled water. So if we repeat the activity with distilled water, we will see that the tester is used, the distilled water will not show the bulb lighting up. So at present there is no distilled water, but if we have distilled water and we test, then the bulb will not light up. Now if I want to make the same distilled water a good conductor, then I have to add little bit of salt to it. So let's see if I am having it. Now here I have tried to add some distilled water in this container. Now I am doing the same activity, and when I dip it inside this, you will see that the bulb does not light up. Why is the bulb not lighting up? Because in this container there is distilled water, and distilled water is a poor conductor, so the bulb does not light up. Now what I will do, I am taking this container and I am adding a little bit of impurity. So I have added a very less amount of salt. I have added salt. Now I am mixing it, so it mixes up. Now I will take the same wire and put it in this, dip the two wires inside this, and it was distilled water. Now when I dip it, now you can see that the bulb is lighting up. So why is the bulb lighting up now? Because the salt which has been added in the water has made it a good conductor. So distilled water does not contain salt, therefore it is a poor conductor. But when we add salt to it, then the salt makes it impure and it makes it a good conductor. So this activity shows how does a tester work, and the activity 14.4, which is described in the book, that is explaining the working of a tester. When salt is dissolved in the distilled water, we will get salt solution, and this is a conductor of electricity. Therefore, the salt which we get from different sources, like the water which we get from tap, hand pumps, wells, it is also not pure. So if we will use that water and we will do the activity, it is seen that the lighter may not work. This water is thus a good conductor. The lighter will not work if it is pure, but the water which comes at home, that is not pure. It is containing impurities. The water which you drink, now all of you must be having RO water. If you test it and if the bulb is not lighting up, it means that RO water is also having no minerals. So then it has become distilled water. So if the bulb of the tester does not light up, if the bulb does not light up, then what does this mean? It means that the RO water is having no salts. So that water which is in the RO is unsafe for health. The water which you drink must have some salts in it, which is considered good for health. See, it is mentioned here in a different way. The salts which are present in the water, they are good for health. These salts make water a good conductor. So we should never handle electrical appliances with wet hands. So since this was just a normal battery, this normal battery does not produce high voltage, so we don't get any electric shock. So common salt, when dissolved in distilled water, makes distilled water a good conductor of electricity. So what are other sources? You can add salt, add any mineral present in the water, and conductor of electricity. So this of current, where we have understood that activity should always be done with a low voltage battery. So this is just a battery which is a 6-volt battery. It is not heavy battery, so it does not give you electric shock. And the wires are connected. So I hope you have understood that how does a tester work, the working of a tester. And let's quickly revise what is a tester. A tester is nothing. It is a battery connected with wire. One is connected to the positive terminal and one is connected to the negative terminal. So there is plus and minus on this. So one wire is the plus, another one is the minus, and the wires are connected to a bulb. And when the wires are connected, then the bulb lights up, which means the circuit is complete. If you separate it, then the bulb does not light up. If you put the two wires inside any liquid and the bulb lights, it means the liquid is a good conductor. That is why we call it a tester. So now we will continue with the next topic in the next class. In the next class, you will understand the working of a tester more in detail. The working of chemical effect of current is described in activity 14.6, and there is in the next class we will continue more with the use of electric current, and we will do the next activity. I will show you this activity, testing of a potato, that it is a good conductor. And if you see this diagram carefully, it is showing you change in color. We will see that it actually happens or not. So if you have any comments or suggestions, type below this video and watch this and stay connected with us, and see you in the next class. Goodbye and take care.